Welcome to the Sleepy Science channel, and hello. We're going to one of the planet's most captivating natural beauties tonight. We'll travel far north to places where the sky itself is a riot of color and light. We'll investigate the northern lights, often known as the Aurora borealis. For thousands of years, this phenomena has enthralled people, igniting tales, motivating explorers, and serving as a constant reminder of our close ties to the sun and the earth. In addition to being commonplace, the northern lights are also remarkable. Even though they occur frequently in some regions of the world, those who see them are always in awe. Their patterns are predictable, but each appearance is distinct. They are a dance of light strewn throughout the blackness, of solar wind and atmospheric gases, of physics and magnetism. Take a seat and allow the tale of the aurora to lead you to sleep, whether you have ever wished to see them or you just want to comprehend the silent magic that takes place in the polar night. The old mystery. People looked up in awe and terror long before scientists figured out the principles underlying the northern lights. In order to explain the glistening curtains of light that occasionally filled their night skies, the indigenous peoples of the Arctic, the Inuit, the Sami, and the numerous northern latitude nations created their own myths. These were sacred stories that were interwoven into their societies, survival techniques, and most profound spiritual beliefs. They were not just explanations. The auroras made friends in the gloom of the Arctic winter, when the sun disappears for weeks or months. The ghosts of their ancestors were depicted by the Inuit as playing a game of ball in the heavens and kicking a walrus's head back and forth. This wasn't just a fancy word. They were able to make sense of the odd and lovely phenomenon by integrating the aurora into their worldview. There was a glimmer of reality in the statement that the lights danced as though they were playing. Although the partners are fields and particles rather than souls, the aurora is in fact a form of cosmic dance. Other cultures in the north came up with their own interpretations. In order to avoid drawing harmful supernatural attention, the Sami people who herd reindeer in Scandinavia cautioned against whistling or waving at the lights. According to some reports, the aurora could be a sign of impending death or bad luck. Nevertheless, there was reverence and recognition that something strong and unearthly was happening above them even in these warning stories. In their famous sagas and mythologies, the Norse peoples occasionally interpreted the lights as fires or reflections from the Valkyries' armor and weapons, female warriors who selected the dead on battlefields. As cosmic battles unfolded in the sky, the lights turned into war lights. This depiction captured something authentic about the aurora, while also reflecting their culture's concern with battle and the paranormal. The collision of solar energy with Earth's magnetic shield is, in fact, a form of violence. We may discover something significant in these ancient understandings as we lie here and reflect on them. Humans glanced up and attempted to interpret what they saw before the invention of spectrographs and satellites, before the ability to monitor ion temperatures and solar wind speeds. By connecting the sky to their lives through culturally significant stories, they were able to make the enormous and unfathomable at least partially understandable. We still, in a sense, do the same. We just use different tools and a different language these days. The beginning of scientific knowledge. After being incorporated into the myths of ancient peoples, the Northern Lights continued to be a mystery to the general scientific community for decades. In Europe, during the Middle Ages and Renaissance, the lights were frequently interpreted from an astrological or theological perspective. They were signs from heaven, portents, and omens. Anders Celsius, a Swedish scientist, in 1621. Indeed, in Uppsala, Sweden, the guy whose name is now affixed to a temperature scale started making more methodical aurora observations. Even Celsius, however, who was trained in science, found it difficult to explain the phenomenon. Formal science was still largely in the dark about the aurora. As the scientific revolution advanced in the 1700s and 1800s, more researchers focused on the north. To investigate the lights, scientists journeyed to the Arctic and subarctic regions. In an effort to identify the circumstances that led to the aurora and potential physical explanations, they conducted in-depth observations. They observed that disruptions in Earth's magnetic field appeared to be correlated with auroras. Greens, reds, purples, and blues were among the hues they noticed in the lights, and they attempted to figure out why. Understanding electricity and magnetism was one of the major discoveries. Scientists started to assume that the aurora was connected to magnetic and electrical processes in the 19th century. It is possible that the aurora was produced by the interaction of the sun's charged particles with Earth's magnetic field. This was still speculative, though. There was still no concrete evidence. The true change occurred in the 20th century with the emergence of the space age, which allowed researchers to study the magnetosphere from above and put satellites into orbit to detect the solar wind directly. All of a sudden, everything came together. There was no magic, mysticism, or divine intervention behind the aurora. Physics was involved. Physics that is attractive, elegant, and easy to understand. The hidden power of the sun and our stars. We must start with the sun in order to fully comprehend the aurora. As it might seem from Earth, our sun is not a straightforward, steady ball of burning gas. It is a roiling inferno of magnetic fields and nuclear processes, a dynamic, chaotic monster. It's nearly impossible to understand the extremely high temperature and pressure at the sun's core, where hydrogen is continuously fusing into helium. The energy that drives all life on Earth is released during this process. However, it also produces a steady flow of charged particles. The sun does more than just radiate heat and light. Additionally, it releases what scientists refer to as the solar wind, which is a constant stream of charged particles that emanate from the sun in all directions. These particles are mostly protons and electrons. The sun's magnetic field is carried by this solar wind, which is constantly present and flowing. This breeze appears to be quite mild when we observe the sun on a calm day. However, the sun isn't always silent. There are events on the sun's surface that, given their size, appear almost violent. The sunspots come and go. Strong magnetic activity is present in these areas. Regular occurrences of solar flares, which are abrupt, powerful energy eruptions on the sun's surface, send radiation blasts across the solar system. Even more spectacular are coronal mass ejections, or CMEs, which occur when massive bubbles of magnetized gas are ejected from the corona, the sun's atmosphere. At millions of kilometre-hours, these occurrences have the power to launch billions of tons of material into space. The solar wind becomes more stronger during these occurrences. It is now a gust, a storm, or a torrent, rather than a light wind of particles. The sun sends this in the direction of Earth. The magnetosphere, or Earth's magnetic armor, acts as a barrier, protecting Earth from the worst of this activity most of the time. Imagine an invisible shield around Earth. Our magnetic field, which is created by the whirling of molten iron in the Earth's core, acts as this shield. Our planet is surrounded by a protective bubble made of the magnetosphere, which stretches far into space. We are shielded from the severe impacts of the solar winds by this shield. Although the magnetic field reaches tens of thousands of kilometers outward, it is strongest close to the Earth's surface and becomes weaker with distance. The pressure of the solar wind shapes the magnetosphere. The solar wind compresses the magnetosphere on the side of Earth that faces the sun, drawing it nearer to the planet. The magnetosphere is stretched out on the other side, creating a long tail that stretches into space and occasionally as far as the Moon and beyond. This magnetosphere is neither static nor inflexible. It is dynamic, flexing and altering all the time in reaction to changes in the solar wind. The magnetosphere retains a comparatively steady structure when the solar wind is mild. However, a coronal mass ejection or a sharp rise in solar activity can cause the magnetosphere to become unstable, squeezed, and warped. Importantly, the magnetosphere's form in the polar regions is especially intriguing. The magnetic field lines form a funnel-like structure as they converge toward the north and south magnetic poles. These are not solid field lines. They are areas of space where a certain direction of the magnetic force is present. However, they are remarkably effective at directing the motion of charged particles, the clash of worlds. At this point, the aurora starts to appear. The solar wind's charged particles are not equally deflected or simply stopped when they come into contact with Earth's magnetic field. The lines of the magnetic field are followed by the particles. They are directed downward toward the high atmosphere and toward the polar regions. Most of the protons and electrons that make up the solar wind are invisible. We cannot see them, but they carry energy. Something spectacular occurs when they strike the upper atmosphere, which is located between 100 and 300 kilometers above the surface of the Earth. When space particles strike Earth's atmosphere, they impart energy to the atoms and molecules, mostly nitrogen and oxygen. After absorbing this energy, these atmospheric gases get agitated. When an atom's electrons have leaped to higher energy levels, it is said to be excited in physics. However, atoms that are stimulated desire to revert to their initial condition. They must expel the energy they have received in order to accomplish this. They emit this energy in the form of light photons. The aurora is this. The type of atmospheric gas involved and the altitude at which the impact takes place determine the color of the aurora. When energized, oxygen atoms usually release two main wavelengths of light: a deep red light at around 630 nanometers and a green-yellow light at about 558 nanometers. The majority of auroral displays are dominated by the green-yellow line, which gives the northern lights their distinctive, vivid green glow. Reds and blues are produced when nitrogen is agitated. The lights are often green at higher elevations when oxygen is more plentiful. Extremely powerful displays can produce all of these colors simultaneously, forming a stunning rainbow of light across the Arctic sky. Blues and purples may arise at lower altitudes or when there is significant nitrogen participation, the preferred latitude for auroras. The auroral oval would be traced if a circle were drawn around the Earth at a latitude of about 65 degrees north. The best place to see aurora activity is this oval. It travels through portions of Siberia, Scandinavia, Canada, and Alaska. During geomagnetic storms, which are times of high aurora activity brought on by powerful solar wind disturbances, the auroral oval is most noticeable. However, in regions such as northern Canada, Alaska, Scandinavia, and Iceland, auroras of some kind frequently occur within this zone. During the clear, dark season, the aurora can be seen on numerous evenings throughout the year. During the winter, aurora displays can be seen in certain places multiple times a week. Throughout much of the winter, aurora may be visible on clear evenings at the most isolated locations and highest latitude communities. For example, there are about 240 nights a year when the aurora displays in Fairbanks, Alaska. However, a lot of these displays may be faint or happen when the sky is still twilight blue instead of completely dark. The Earth's magnetic field's shape explains why the aurora focuses in this oval. The magnetic poles, which do not precisely match the geographic poles, are where the magnetic field lines converge. In this auroral zone, instabilities are mostly caused by the interaction of the magnetosphere with the solar wind. The auroral oval appears to be marking a crack in the magnetosphere. Similar to how people in temperate latitudes experience rain or snow, those who reside within the auroral oval perceive aurora as a normal aspect of their surroundings. Some people in the far north have grown up seeing the aurora every winter night, going outside in the bitter cold to catch a glimpse of the lights before heading back inside their cozy houses. However, it rarely gets monotonous, even for people who are used to witnessing the aurora. Every show is different and never exactly the same as the ones that came before it, unless there are really strong geomagnetic storms that bring the auroral oval closer to the equator. People living farther south hardly ever see the aurora. The aurora may be visible from even further south during the most intense geomagnetic storms, which happen around once every 10 years. The aurora was visible from Cuba in 1989 due to a powerful geomagnetic storm. The aurora has been observed in other severe storms from Europe, the southern United States, and even to equatorward. These few occurrences serve as a reminder to those of us who reside in more temperate latitudes that the aurora is always present and could be seen if the right circumstances are met. The aurora fluctuates. There may be a faint glow along the northern horizon on a calm northern night, a weak luminescence that hardly rises above the stars. Low-level solar wind and magnetosphere activity is the cause of this subtle auroral glow. However, things alter after that. The aurora occasionally awakens over the course of an hour or so. Suddenly, a barely perceptible weak arc becomes brighter. The arc starts to dance and ripple. Across the sky, curtains create sweeping, folding sheets of light. The green gets brighter and more powerful. The aurora appears to be pulsing with energy and almost alive. This is an auroral substorm, which is a time of increased activity that could last anywhere from 30 to 60 minutes. The quantity of energy released into the sky during a substorm is astounding. Particles suddenly speed quickly after floating along magnetic field lines at a modest pace. Where the intensity of energy deposition is highest, bright auroral curtains form. Even from areas with some light pollution, the aurora may be bright enough during a substorm to illuminate the snow-covered ground and cast shadows that are plainly visible. Substorm's physical process is still not fully understood, even by the professionals in the field of aurora research. We do know that over time, the magnetosphere gathers energy from the solar wind. On the night side of the magnetosphere, the stretched magnetic field lines retain this energy. This accumulated energy is then abruptly released in a devastating way. Particles speed up. Different arrangements of magnetic field lines cause them to snap and rejoin. The aurora brightens substantially as a result of massive energy flowing downward into the atmosphere. A substorm is typically the most impressive aspect of an auroral display for onlookers on the ground. The aurora changes from being a soft background glow to becoming more vivid and dynamic. Along auroral curtains, waves travel. From the horizon, rays ascend in the direction of the zenith. In the east or west, new arcs emerge and spread out over the sky. A substorm is frequently the aim for someone who has traveled north, especially to observe the aurora. The colors of the night, when the lights really come to life. Let's take a closer look at the hues while we lie here and see the aurora dancing overhead. Soft green-yellow light is the most prevalent auroral color. At elevations between 100 and 150 kilonewtons, oxygen atoms are the main source of this. The wavelength, 558 nanometers, is so characteristic that it is frequently referred to as the auroral green line. If you haven't seen it in person, it's a color that's hard to describe precisely. It's not exactly like any green on Earth. With its own intrinsic light, it appears almost ethereal. The aurora's brightest region is frequently this green. Pictures and descriptions are dominated by color. It's not the only hue, though. A vivid red light at 630 nanometers is emitted by oxygen atoms triggered by particle collisions at higher elevations, above 300 kilometers. Under typical conditions, this red is approximately 100 times fainter than the green. However, the red is apparent during extremely powerful outbursts, frequently manifesting as a red glow at the top of auroral curtains or a reddish corona above. Usually during the most strong auroral displays, the reds and purples emerge alongside the greens. Beautiful visual effects can result from color transitions. In order to create a rainbow-like effect, an auroral curtain may have a green lower edge and a crimson glow above it. Occasionally, purple hues also emerge, which are typically a combination of the red and blue hues that nitrogen produces. Nitrogen is the source of the blues, which usually occur between 100 and 300 kilometers below the red oxygen line. Depending on the intensity of the exciting particles, nitrogen can produce both red and blue hues. However, the blue is often less bright than the red and green, and is only seen during extremely intense displays or close to the bottom of auroral curtains, where nitrogen is more prevalent. The way the hues of the aurora convey information about physical phenomena is one of its most intriguing features. The energy of the particles responsible for a certain auroral phenomenon can be inferred from its altitude. The composition of the atmosphere at various elevations can be inferred from the relative brightness of certain colors. By examining the colors of the light, aurora researchers can actually discover information about atmospheric characteristics. In actuality, the aurora is writing a torrent of scientific data across the sky. The dance of magnetism and light. The aurora isn't arbitrary. There are patterns even if every auroral display is different. The fundamental physics of the interaction between charged particles and magnetic fields is reflected in these patterns. The auroral arc is one of the most prevalent auroral patterns. Een heldere lint van licht dat de lucht doorkruist en vaak ongeveer oost-west loopt, wordt een boog genoemd. The arc may be diffuse and fuzzy or sharp and well-defined. For minutes or hours, it may stay comparatively steady, or it may continually brighten and fade. An arc is an area where a large number of particles are being accelerated to energies high enough to emit visible light, and where the precipitation van particles is concentrated in a small area. Arcs frequently disintegrate when particles speed up and the auroral activity increases. The arc acquires structure as opposed to being a straightforward, smooth arc. From the main arc, pillars of light shoot upward into the zenith in the form of bright, narrow beams. These rays are sometimes referred to as auroral streamers or curtains. Dozens of rays, each tens of kilos broad, may stretch hundreds of kilos into the sky in a really dynamic display. These rays seem to extend toward the zenith immediately overhead to a ground-based viewer. However, in practice, they typically slope because of the magnetic field's orientation. The rays are not motionless. Ze ripple and shimmeren. Ze vaden en verlichten. They occasionally pulse, becoming brighter and dimmer in a steady beat. Ze kunnen af en toe draaien in helicale of spiraalvormen. Seeing an auroral curtain is like witnessing something nearly alive, as if it were breathing and dancing in accordance with unknowable laws. If you turn away or blink, The movements are normally too slow to see in real time, but slow-motion video shows the subtle dance that's always going on. The auroral corona is another typical pattern. Directly above the corona, when a particularly spectacular show peaks and you are standing beneath the aurora, it may appear as a crown or halo. Een zeer opvallend driedimensionaal effect wordt geproduceerd als de stralen samenkomen rond een punt dicht bij de zeniet. Standing under an auroral corona maakt iemand voelen klein en een deel van iets groots en krachts. Tussen shows, de aurora die lijkt boven en rondom je te zijn, daalt van alle kanten tegelijkertijd naar beneden. Known as the auroral glow of gently glowing auroras, the aurora may diminish to a mere glow during calmer times. This light has little structure and is diffuse and frequently fairly faint. It is created by low-level particle precipitation, which is insufficiently powerful to produce dazzling curtains or arcs. From a genuinely dark place, a glow aurora may be so weak that it is completely invisible from areas with high levels of light pollution. It gives the night sky a delicate backdrop, the solar and seasonal cycles. Op verschillende temporele schalen fluctueert de aurora. As magnetic circumstances change, there are fluctuations even within a single night. As solar activity waxes and wanes, there are differences from night to night. On longer timescales, there are other differences related to Earth's orbital position and the solar cycle. The gloomy season is when the aurora is most noticeable. Although it is a little further south than Tromsø at 62 degrees north latitude, it is still firmly within the auroral oval. The city is now somewhat of a destination for aurora viewing. Aurora cabins are scattered around the city's surroundings. Tourists can observe the lights from inside these little heated buildings while staying comfortable. Many people now consider watching the aurora through a large window at a suitable temperature while sipping hot beverages and relaxing in cozy chairs to be the norm. Aurora displays are considerably more common in Fairbanks, which is located at roughly 65 degrees north latitude, than in places that are slightly lower. One of the top geophysical institutes in the world is run by the University of Alaska Fairbanks, where researchers examine space weather and the aurora. The aurora is close enough to Fairbanks for locals to consider it a typical wintertime occurrence. In the same way that someone in a southern city could see rain in the afternoon, a local might look out and see the lights dancing. However, the aurora is still unique even at these locations. A display that is unusually brilliant, has uncommon hues, or lasts unusually long. People discuss these topics, locals point them out to visitors, and photographers are motivated to wait for the ideal snap for hours in the cold. Even in locations where it happens frequently, the aurora never becomes boring. The history of Earth and the aurora. For millions of years, as long as there has been a magnetic field on Earth, people have been able to observe the same aurora as we see today. However, across Earth's history, the aurora's appearance has evolved. And being aware of this past makes us appreciate what we have today. The magnetic field of Earth has changed over time. In actuality, the Earth's magnetic field reverses on average every 200,000 to 300,000 years. The magnetic poles on the north and south alternate positions. The field weakens significantly during these reversals, which can take 1,000 to 10,000 years to finish. The aurora would have been much more dramatic and visible from much further south than it is now during such periods. At the equator, the aurora might have been a frequent sight, and the auroral oval would have grown significantly. More recently, there was a protracted return to Ice Age-like conditions approximately 11,700 years ago, during what is known as the Younger Diuous Era. According to some experts, this climatic reversal may have been caused by an impact by a comet or asteroid. If such an impact had taken place, it may have been seen from the surface of the Earth as a dazzling sky display, possibly both during the day and at night. According to some theories, the ancient astronomical occurrences that are mentioned in mythology all throughout the world may have been allusions to very bright auroras that occurred during times of intense solar activity or a particularly weak magnetic field. It is evident that the aurora has always been a component of the Earth's system, the global auroral dance, even though this is still purely hypothetical. The aurora borealis, also known as the Southern Lights, is a phenomena that occurs at southern latitudes and is comparable to the Northern Lights, which have received the most attention and have been the subject of much research. The Antarctic, the far south of Australia, New Zealand, and southern Chile and Argentina are the most popular places to see it. The South Magnetic Pole's auroral oval produces stunning displays similar to those in the north, but in different places. Although they are not precisely coordinated, the northern and southern auroras are essentially mirror images. The same solar wind disruptions cause them to happen at the same time. However, the appearance and behavior of auroras might vary slightly depending on the local conditions in each hemisphere and the magnetosphere's geometry. With the development of satellite technology and the collection of decades' worth of observations, scientists have just started to see the northern and southern auroras as components of a global system rather than as separate phenomena. The magnetosphere receives energy from the solar wind, which is then dispersed into the atmosphere as particle precipitation and concentrated in the auroral oval regions at both poles. This causes the aurora to occur simultaneously in the Arctic and the Antarctic, making it more than just a local occurrence. Acceleration physics. How the particles are driven to such high energy is one of the major mysteries that aurora experts are still trying to solve. The temperature in the high atmosphere, where the aurora is seen, is extremely low, just a few hundred degrees Kelvin. However, the energy of the particles that produce the aurora is comparable to temperatures hundreds of degrees higher. They are being accelerated to these energy by something. Numerous potential mechanisms have been identified by scientists. One is acceleration along magnetic field lines in areas with electrical fields or a strongly curved magnetic field. Acceleration during magnetic field line reconnection is another. The lines release energy that can be used to accelerate particles when they break and reconnect in a lower energy configuration. A third entails interactions between waves and particles, wherein particles can receive energy from plasma waves in the magnetosphere. There is ongoing discussion and investigation regarding the relative significance of these several pathways. We continue to collect data from modern satellites equipped with sophisticated particle detectors to better understand how this acceleration takes place. It serves as a reminder that mysteries still exist even after decades of space-age research and centuries of aurora observations. We continue to learn about the basic physics of charged particle behavior in electromagnetic fields from the aurora. Deep time's colors. We may reflect on the connection between the aurora and deep time as we sleep and see it. The aurora that we see now has existed for around 4.5 billion years, or as long as the Earth has had an atmosphere and a magnetic field. Since the auroral oval was farther north when our ancestors lived in Africa millions of years ago, they would not have been able to routinely observe the aurora. However, the aurora may have been observable from lower latitudes during times when the magnetic field was weaker or during periods of exceptionally high solar activity. The aurora would have been a common sight to our more recent predecessors, the people who moved north into the Arctic over the last tens of thousands of years. The aurora was incorporated into the myths and world views of the tribes that sprang up in these northern areas, They used the stories they told about the lights, the dancing spirits, the cosmic conflicts, the warnings, and the omens to give meaning to something that was exquisite, enigmatic, and completely outside their control or comprehension. With today's scientific knowledge, we can identify the cause of the aurora when we observe it. We comprehend how charged particles interact with atmospheric atoms, as well as the solar wind and magnetosphere. We are able to reasonably forecast when auroral displays will be at their strongest. We have satellite networks that assist us predict aurora activity and alert us to solar storms. However, there is still something fundamental from those earlier viewpoints. The aurora remains stunning, enigmatic in all its intricacies, and humble in its majesty. Although the mechanism is explained by physics, the wonder is not lessened. The aurora hunt of today. Nowadays, both scientists and tourists are interested in aurora hunting. Space weather prediction facilities provide online forecasts for auroras. These forecasts predict geomagnetic activity for the next 3 hours, 1 day, and 3 days out using real-time satellite data. To determine the probability and severity of aurora activity, they employ the K-index, a scale that ranges from 0 to 9 and measures geomagnetic disruption. In general, aurora is likely to be visible in the auroral oval zone when the K-index is 3 or higher. More intense activity across a larger region is indicated by higher K indices. In order to maximize their viewing prospects, professional aurora photographers have learnt to constantly monitor these forecasts, keeping an eye on weather patterns for clear sky. They are aware of the best spots in the auroral zone, the places with the best views of the north, and the places with the least amount of light pollution. Numerous hours of observation have taught them that the aurora is most likely to be active between midnight and 4 a.m., and they plan their evenings appropriately. In many northern settlements, tours of the aurora have grown to be a significant source of revenue for tourists. From straightforward aurora hunts in heated vans to more unusual choices like seeing the aurora from above in an airplane or from specialist lodges made especially for aurora watching, tour operators provide a range of experiences. Dedicated aurora seekers will stay in the north for several nights in hopes of catching the ideal mix of clear sky and active geomagnetic conditions. Many will keep going back because they can't get the lights out of their heads. A wide range of scientific tools are used in contemporary aurora study. Magnetometers on the ground provide real-time information on geomagnetic activity by measuring variations in the Earth's magnetic field. At aurora research sites, all sky cameras are frequently set up to record auroral displays by taking pictures continuously or at regular intervals. To determine which atmospheric gases are being excited at what times, several of these cameras isolate particular emission lines using specialized filters. In fact, radar devices such as Alaska's PFISR and its flat incoherent scatter radar are capable of measuring ionosphere characteristics with a high degree of accuracy. At various elevations, they are able to measure temperature, velocity, and electron density. During auroral substorms, they can monitor changes in these characteristics. They give details about the particles themselves, including their density, energy distribution, and motion directions. Satellites are essential in space. Instruments that measure the Earth's magnetic field, the solar wind, and energetic particles in the magnetosphere are carried by satellites such as the Theus spacecraft. Before the aurora is visible on Earth's surface, these data let scientists understand what's happening in space. Certain satellites are made expressly to observe the aurora from above, assessing the spectrum characteristics of auroral emissions and gauging their brightness. A comprehensive image of what occurs during an auroral display is produced when you combine all of these devices, both space-based and ground-based, that measure particles, fields, and light. However, despite all of this data and technology, scientists are still surprised by some elements of the aurora. Current ideas don't adequately account for certain aspects of auroral displays. There are still some unanswered questions regarding the specific mechanisms of particle acceleration. The night's beat. Now picture yourself sitting outside on a winter night in the far north. The temperature is probably -20 or -30 degrees Celsius, which is much below zero. Above you, unaffected by the atmosphere or light pollution, the stars are dazzling. The Milky Way, a river of light across the dark sky, is plainly visible. The air is crystal clear and still. Any available light is reflected by the snow, giving the surrounding area a mild blue-grey glow. You don't know if the aurora will show up. Although the forecast indicated potential activity, such forecasts are not always accurate. You hold off. Clouds of crystalline wetness rise before you as you breathe. Even with mittens on, your fingers start to tingle. Even when your clothing is bulky, your legs get cold. Waiting in the cold during the long night challenges one's forbearance and resolve. A faint glimmer along the northern horizon is the next thing you notice. At first, it's hardly noticeable, just a faint brightening, a brilliance that could be confused with the last of a sunset or the illumination from a far-off metropolis. However, you are aware that there are no cities in that area. You looked at the map. The aurora is this. For a long period, the radiance is not overt. 10 minutes go by, then 20. Gradually, the illumination gets brighter. It shows the outline of an arc, a bright line that stretches across the northern sky from east to west. It's green, but it's a delicate, almost dreamy green. There are some irregularities in the arc. Along its length, there are faint waves and fluctuations in brightness. After the awakening, something changes. The arc gets brighter. The light suddenly becomes substantially brighter. The green gets more intense and vibrant. The once merely visible arc takes on a spectacular appearance. The snow begins to take on shadows as the brightness rises. Shadows, thin and blurry, but shadows nonetheless. The arc starts moving. It trembles. From east to west, waves travel along its length. At first, the ripples are hardly perceptible, but as they grow, they become obvious. There is movement in the aurora. It is active, vibrant, and teeming with life. The arc then disintegrates. From the main arc, bright beams shoot upward, light pillars extending to the highest point. These are the streamers, the auroral rays. Their verticality isn't perfect. The magnetic field's inclination causes them to tilt. Not all of them are razor sharp. They are definitely there, even if they shimmer and ripple. Columns of bright green light extending toward the stars. Rays start to form in greater numbers. Soon the sky will be covered in hundreds or maybe dozens of them. They don't stay the same. They fade and brighten. New ones that originate from other areas of the arc eventually replace those that fade altogether. Some form helical or spiral shapes. Some pulses appear to be breathing as they gradually get brighter and dimmer in a steady beat. There is complete silence in the scene. The aurora is silent. It doesn't pop, crackle, or hum. There is a tremendous quiet. The crunch of snow beneath your feet is the sole sound. The noises of winter itself. If you move, you could hear the distant sound of wind or the occasional burst of ice expanding in the cold. Even while the aurora doesn't make noise, its striking appearance nearly makes you anticipate it. The experience becomes even more bizarre and dreamy due to the cognitive dissonance caused by the separation between the visual drama and the quiet. You stand in awe. The cold almost becomes inconsequential. Your full attention is on the sky and the light dance that is taking on above. The regular meaning of time seems to be lost. As the minutes go by, it seems like hours and seconds are happening at the same time. You may have spent 5 or 50 minutes watching. Your sense of time is no longer accurate. The rays are still dancing. They vibrate and glitter. At intervals, the whole show becomes substantially brighter, and the landscape seems briefly as though it were twilight instead of deep night. The brightness then diminishes once more, reverting to the fainter glow. However, the beams stay strong the entire time, enduring light pillars that aim toward the dance's apex, the stars. If you're lucky, the display peaks if the geomagnetic storm is strong enough and the correct circumstances exist. It could take an hour or 10 minutes of increasing exercise before this occurs. But it's obvious when it does. The aurora gets quite bright. It appears as though someone is beaming the green light from below the horizon since it is so bright. The rays keep growing. There could be hundreds instead of dozens, so many and so near to one another that they create an almost continuous curtain of light instead of discrete individual beams. Like a curtain caught in a breeze, the curtain undulates and ripples. However, the magnetosphere is this breeze. Additionally, the movement of charged particles through the Earth's upper atmosphere is what propels these movements. Additionally, you may be able to see the auroral corona if you are in a good position when the brightest area of the display is directly overhead. All of a sudden, the aurora that has been limited to the northern horizon appears to be all around you. Rays converge overhead toward a point just above your head after shooting upward in all directions. It's a breathtaking, nearly overwhelming effect. You have the impression that light is all around you, embedded in a three-dimensional brightness structure. The sky is no longer something you gaze up at in the distance. It is now something that surrounds you and makes you feel as though you are inside it. Eventually, this intense time will pass, even though it may linger for a few seconds or for several minutes. The display goes through a phase of gradual fading as the brightness decreases and the rays get weaker. The exhibit frequently becomes even more lovely in a different manner as it fades. The aurora is bright and dramatic at its height. However, it frequently gets more delicate and elegant as it fades. The green may soften and become more ethereal. It is possible for the rays to acquire a translucency or shimmer. At higher elevations or at the margins, there may be hints of crimson or purple, making the colors more complex. As the geomagnetic activity decreases, some displays gradually darken over several minutes. Others fade faster, returning in a matter of minutes to a mere light or perhaps a simple arc. Rarely, however, does the display just get dark as it fades. Instead, it returns to a softer state, a luminosity on the horizon, a glowing arc, maybe a few dim beams. Another display may start after a quiet interval, or the aurora may fade to nothing and stay at this milder intensity for hours, giving the night sky a delicate background. Auroral activity frequently consists of quiet intervals interspersed with powerful, episodic displays. In a single aurora activity night, there may be 3 or 4 different substorms with quieter periods in between. There is a build-up phase, a peak, and a fade in every substorm. However, every substorm has its own specifics. All of them are unique creations that are not like any other show or exhibition in the future. The beauty and the physics. We may be able to appreciate the aurora on a deeper level as we rest here, now that we know what we're looking at. An oxygen atom in the Earth's upper atmosphere is responsible for emitting each photon of green light that you are currently viewing. an electron or a proton that came from the solar wind particles that were released from the Sun and traveled for hours through space to reach Earth, impacted the oxygen atom. The Earth's magnetic field's large-scale structure can be inferred from the ray pattern. The inclination of the field lines at that latitude is revealed by the ray's inward tilt toward the magnetic pole. The strength and position of the particle precipitation are shown by the brightness distribution. We can learn about the atmosphere's composition and particle energy from the hues. Wave structures in the plasma are shown by the minute changes in brightness. The variations from one instant to the next are a reflection of the magnetosphere's ever-changing magnetic circumstances. The interplay between the Sun and Earth is actually visualized in real time by the aurora. The invisible forces that are always at work around our globe are being written across the sky by nature. You're viewing basic physics, how charged particles behave in electromagnetic fields, and how the solar wind interacts with a planetary magnetosphere. Beautiful stories written in light were made visible by the excitation and de-excitation of atomic states. Arctic indigenous peoples who witnessed displays similar to the ones you're picturing now made up stories about them. Something authentic about the aurora is captured in the Inuit story of spirits using a walrus head to play ball. The feeling of play, of game, of motion without any apparent reason. There is some truth to the Sami people's advice not to whistle at the lights. In the actual supernatural meaning they envisioned, the aurora is strong, if not dangerous. Other cultures developed narratives that placed the aurora in the context of their cosmologies, or conceptions of the world and our place in it. Before the development of modern science, the aurora was occasionally seen in Japan as a fire-like portent. In Europe during the Middle Ages and the Renaissance, onlookers frequently saw the aurora as a divine sign or a celestial omen pertaining to human matters. Major auroras were frequently documented in ancient records with accounts of political upheavals, epidemics, and wars, as if there were some connection between the aurora and earthly occurrences. The aurora is not a supernatural omen, according to modern science. Natural laws are the driving force behind this phenomena. However, standing under an aurora show and reflecting on it has a nearly spiritual quality, the feeling of being a part of something huge, cosmic, and completely outside of human control. This is true. At the same time, the variety of auroral displays may be explained by physics, not mythology. Auroras vary in appearance. The geomagnetic storm's strength and features, the local time, the season, and numerous other variables all affect how different the displays are. On the northern horizon, a weak aurora may appear as a faint glow that is hardly perceptible from a dark place. Most folks don't observe such displays. Bright arcs and possibly some beams or curtains are visible in a moderate aurora. When most people think of the northern lights, they picture them, bright, observable from a great distance, clear and lovely, without being overly intense. A powerful aurora turns into a noteworthy occurrence. Cities with a lot of light pollution may be able to see the display. It could be bright enough to cast distinct shadows over snow-covered land. It may display purples, reds, and greens as it changes color. For someone going through this, it feels like a significant occasion, something to remember and share with others. The intensity of a really strong aurora, the type that happens during the strongest geomagnetic storms, becomes nearly overwhelming. The landscape may be illuminated by the aurora as brightly as, or even more so than by moonlight. The show may push down toward lower latitudes where aurora is typically infrequent or non-existent, extending well beyond the typical auroral zone. These kinds of performances are honored and remembered. The auroras that happen during the strongest geomagnetic storms are the rarest and most severe. The aurora was visible from the Caribbean during the Carrington incident of 1859, one of the most powerful geomagnetic storms ever recorded. Strong auroras were visible across the southern United States and even from equatorial nations during the May 2024 geomagnetic storm. These occurrences serve as a reminder that although the aurora typically appears in a predictable area, in very rare cases it can enlarge significantly. The colors of extreme displays. The typical aurora colors, the distinctive green, the less common red, the faint blues and the purples, have all been covered. However, the whole range of auroral colors can show up in the most extreme displays. Because of their varying elevations, the red and green oxygen lines may appear simultaneously, producing a tiered rainbow-like image. Nitrogen's blues and purples can be very noticeable. The sky can resemble a rainbow aurora at the utmost intensity of a show, with greens, reds, purples, and even faint hints of other colors, all visible simultaneously. The aurora may seem nearly unreal in these extreme situations. Because these displays surpass people's preconceptions of what the aurora should look like, those who encounter them frequently find it difficult to describe them. As though the sky had changed into something unearthly, some people characterize them as alien. Some say they are the most exquisite object they have ever laid eyes on. One of the top experiences that many aurora watchers aspire to is seeing a truly intense show with full-spectrum colors, the cycle of auroral substorms. Researchers that research the magnetosphere have discovered a very consistent pattern in the formation of auroral substorms. We refer to this as the auroral substorm cycle. Knowing this cycle makes it easier to forecast when the aurora will most likely be active. There is a growing phase at the start of the substorm cycle. The magnetosphere receives energy from the solar wind during this period. On the night side, the magnetosphere gets more and more stretched out and warped. The inner magnetosphere starts to fill with particles. Although it isn't yet bright, a slight auroral arc may be seen on the ground. Though not yet unleashed, the energy is being held. A few minutes to more than an hour may pass during this growing period. Satellites in orbit record growing particle populations during this period, while magnetic detectors on the ground record rising activity. However, the change may be modest or not immediately apparent to someone observing the sky. The barely perceptible faint arc might still be there, perhaps with a little more form. The expansion phase follows. Something shifts. Research on the precise methods is still ongoing, but all of a sudden the stored energy is released. Previously restricted particles are now accelerated to high energy. From the main auroral arc, bright auroral rays exploded upward. The aurora becomes significantly brighter. The auroral oval as a whole becomes considerably more active. The most noticeable stage is this one, the stage that attracts viewers of the aurora. The most amazing visual phenomena take place during the expansion phase. The auroral corona, the various colors, the dazzling rays. Although it might be shorter or longer, this phase usually lasts 10 to 30 minutes. During this phase, the aurora reaches its maximum brightness before progressively fading. And lastly, the recuperation stage. The activity level drops, the brightness drops, the rays diminish, and the aurora returns to a simpler arc or glow. The duration of this stage can range from a few minutes to more than an hour. During recovery, particle populations are declining, and the magnetosphere is progressively reverting to a more stable shape. If the solar wind activity has sufficiently slowed after recovery, the cycle may come to an end. However, the cycle may recur if conditions for a strong solar wind continue. A new stage of growth starts. Another phase of expansion takes place as energy builds up once more. 3, 4, or even more whole substorm cycles could make up a single night of intense aurora activity. The absence of the sound. Whether the aurora produces sound is one of the long-standing questions surrounding it. They might imply that under some circumstances, there might be ways for extremely low-frequency sound to travel from the magnetosphere to the Earth. Unknown effects on human perception could result from the production of infrasound sound frequencies, which are too low for human hearing. The question is still open. The majority of scientists continue to doubt that the aurora emits sound at ground level. However, it is impossible to completely discount the persistent reports from Arctic peoples, especially the Smai. It's plausible that some system does make sound in some situations, maybe during especially powerful displays or at specific locations. Another possibility is that people psychologically associate sound and visual phenomena, such that when they stare at the aurora, they may inadvertently hear sounds that the aurora doesn't truly create. This conundrum serves as a reminder that even things we believe to be completely understood can nevertheless surprise us. The aurora can still show us unexpected things, even after decades of satellite monitoring and advanced equipment. The aurora seasons. Seasonal variations in aurora visibility and intensity have subtle causes. The dark season winter in high northern latitudes or the autumn and spring equinoxes at somewhat lower latitudes are when the aurora is most visible in most places. This makes intuitive sense. You need darkness to observe the aurora. Additionally, more darkness is preferable. It is always dark in places above the Arctic Circle during the polar night of deep winter. Therefore, it is possible to see the aurora at any time of night. However, there is another, more slight, seasonal change. Geomagnetic indices show that aurora activity is often higher around the equinoxes, which occur around March 21st and September 21st, than during the solstices, which occur around June 21st and December 21st. We refer to this as the equinox effect. The tilt of the Earth's axis and how it influences the orientation of the Earth's magnetic field with respect to the solar wind seem to be the cause. In addition, aurora activity has a 27-day cycle. This is equivalent to the duration of the solar rotation. Active zones, or places of high magnetic activity, move into and out of Earth's line of sight as the sun spins. We typically encounter more solar wind disruptions and larger geomagnetic storms, which result in more intense auroras when a very active region faces Earth. Activity tends to decline as the sun revolves and that active zone moves away. The 11-year solar cycle is another. Aurora occurs at solar minimum, but it is usually weaker and less frequent when sunspots are few and solar activity is low. Aurora displays are typically more frequent and stronger during solar maximum, when the sun is most active. Aurora viewers should anticipate a few years of higher aurora activity than in previous years because we are currently reaching a solar maximum. These several cycles, daily, seasonal, 27-day, and 11-year, overlap and interact in intricate ways. These elements all work together to affect the aurora's activity on any particular night. These forecast the short term using real-time satellite data. By viewing the forecasted K-index for the next few hours, a hunter using an aurora forecast website can decide if it's worth venturing outside. Forecasts about the weather are equally crucial. Even if there is an aurora, you won't see it if the sky is overcast. On nights when aurora is forecasted, many aurora hunters constantly monitor cloud forecasts to find the places with the best chance of clear sky. Cloudy skies, rather than aurora activity, are frequently the limiting factor in areas close to the Arctic where aurora is widespread. Cameras are becoming essential equipment for observing auroras. Some individuals use a camera, tripod, and wide-angle lens, relatively basic equipment, to take pictures of the aurora. Others employ advanced machinery made to detect even the smallest aurora traces. Aurora photographs are frequently more striking than what is seen to the naked eye. Over a period of seconds, the camera can gather light, brightening the screen and bringing out hues that are difficult for the human eye to see. There are now smartphone apps that forecast aurora activity and alert users when the conditions are right. Casual watchers who don't want to constantly check forecasts can now observe auroras more easily thanks to these applications. They merely get a notification when an aurora is expected, at which point they may choose whether or not to go outside. Humanity's quest to strengthen our bond with this natural occurrence is reflected in all of modern technology. There is no change in the aurora itself. It happens whether or not we have cameras, apps, or forecasts. However, thanks to modern technology, we can see the aurora more often, enjoy it more completely, and record it in ways that we can share and save. The quiet beneath the lights. Now let's go back to the scene where you are standing in the middle of the night in the Arctic and viewing an aurora display. The exhibit is currently in a quieter period after the aurora peaked, brightened, and dissipated. The dazzling rays have almost dimmed. There is still an arc with maybe a few faint rays. The display has switched to a softer mode, but it is still lovely. The deep quiet continues. You know how silent it is. The quiet in a snow-covered area, remote from human habitation, can be nearly deafening. The breeze is absent. The silence is absolute. Animal noises are absent. The majority of animals are either sleeping or hibernating. No cars, no music, no voices, no machines, no human sounds. A certain mood was produced by the combination of the aurora's visual beauty and quiet. Many who have gone through this say they feel incredibly calm, at peace, and connected to something greater than themselves. This could be a merely psychological response to silence and beauty. Or there may be more, as some have suggested. It's possible that the aurora's low-frequency electromagnetic oscillations, or the infrasound it is said to produce, have an impact on human awareness that we are not entirely aware of. There is little doubt that observing the aurora in silence on a chilly Arctic night differs greatly from viewing the aurora from a window in a city or watching footage of the aurora on a television screen. Photographs and movies cannot adequately convey the sensation that is created by complete immersion, the use of all senses, the cold air, the sound of your own breathing, the crunch of snow beneath your feet, the sight of lights and the lack of other people. The dance goes on, the aurora show goes on. There might be another substorm. Abruptly the arc becomes brighter, rays form again. The screen comes back to life and is functioning. Maybe the calm period lasts for a long time, and you're left to observe a soft glow on the horizon as the stars above you continue to shine slowly. Time goes on. You may be shocked to see that hours have gone by since you went outside when you check your watch, or perhaps you don't realize how much time has passed. The aurora has the ability to warp perceptions of time and induce a mood that is similar to meditation or flow. The science behind the viewing experience. Your brain is processing a remarkable amount of information while you observe the aurora. Your visual system is following the rays' movements, observing variations in brightness, and detecting the color's minor alterations. All of this information is being combined by your brain into a logical story. The display is present. It is evolving. It's lovely. Furthermore, you are in a state of focus known as flow or absorption, according to neuroscientists. Your typical self-critical thoughts, work-related anxieties, future-related fears, and self-judgments are mostly silent. Your thoughts are fixed on the here and now, on what's happening in the sky above you. It is well recognized that this emotional state improves mental health by lowering stress and anxiety. Regular meditation practitioners and those who participate in flow-producing activities frequently report feeling happier overall. It appears that the aurora is more than just a stunning sight. It's a potentially beneficial experience for the mind. You're doing something almost like meditation when you stand beneath it and observe it. You're letting the dancing lights and the chilly Arctic night calm your thoughts and help you focus on the here and now, the remembrance that is left. You'll have to return inside eventually. You'll conclude there's no use in waiting in the cold any longer. When the cold gets too intense, you get fatigued or the display fades. You will return to the warmth, light, and human civilization of your refuge. However, a remnant of the aurora will stay with you. You will probably remember the encounter for days or even a lifetime. You may often find yourself remembering the presentation in vivid detail if it was especially dramatic. It is possible that you will reflect on how small you felt under the lights, how big the universe is, and how you are a part of cosmic processes that take place far above your head and beyond human control. Numerous witnesses to the aurora said that it altered them in some way. They are more awed by the majesty of natural events, feel closer to nature, and are more conscious of their role in the greater world. Some people say that seeing the aurora changed their outlook on life, helped them focus on what really important, or motivated them to look for more opportunities to experience beauty and connect with nature. In other words, the aurora is more than just a sight to behold, something that affects us. Something has an impact on us and forms a part of our internal memory and meaning landscape. You might go out again the following night to see whether the aurora appears if you're still in the north. More activity may be anticipated based on the geomagnetic prediction. Maybe it foretells calm weather. You'll go out hoping to witness another display if it promises action. You may still go out even if it says it will be quiet. After all, auroras can occasionally emerge unexpectedly, and forecasts are not always correct. If there is a display on the second night, it will be different from the first. It could be more or less bright. Maybe the colors may be more subdued or more vibrant. The display could be shorter or last longer. Especially if the display is the same as what you saw the previous evening, it will feel new and different when you stand beneath it, especially if it has odd features or a traditional pattern. One of the amazing things about natural occurrences is this: they can be repeated, but they will never be the same. No two waves in the water are the same, even though they repeat forever. Every day, the sun rises and sets. Each one, however, is distinct and special. In a similar vein, the aurora that consistently appears in the same spot is both recurring and eternally distinct. Science that is not readily apparent. All of our previous discussions about the aurora have centered on what you can see, such as the brightness, colors, and movements. The activities occurring in the magnetosphere above the aurora, however, are the subject of a whole discipline that focuses on what is invisible. A thin layer of plasma gas that has been ionized so that it is composed of free electrons, and ions rather than neutral atoms makes up the magnetosphere, an area of space that stretches thousands of kilometers around Earth. The Earth's magnetic field threads this plasma. This magnetosphere engages in a complicated tango with the solar wind. The engagement is really mild when it is quiet. Similar to water flowing around a stone in a stream, the solar wind circles the Earth's magnetosphere. However, the contact intensifies when solar wind disturbances occur, particularly from coronal mass ejections that contain powerful magnetic fields. Specifically, a phenomenon known as magnetic reconnection may take place. The energy contained in the stretched field can be released when magnetic field lines break and reattach in lower energy configurations. Particles are accelerated to high velocities by the energy released. The Earth's magnetic field directs these particles as they descend toward the poles. One of the most energetic phenomena in the near-Earth space environment is this acceleration process. During a powerful geomagnetic storm, the energy involved is immense, on the scale of billions of megawatts. This is similar to how much energy human society uses overall. A sizable portion of this energy is being deposited into the upper atmosphere, where it causes the aurora and impacts on Earth, while the remainder is being released in the magnetosphere. Up until now, we have concentrated on the aurora's beauty and mystique as a visual phenomenon. However, the aurora's production processes have broader effects on Earth. Power grids, satellites, and communications can all be affected by a powerful geomagnetic storm. Given how reliant we are on electrical and technological systems in the modern world, even the most powerful storms, like the Carrington event of 1859, might inflict enormous damage. Though it is undoubtedly a component of it, research into the aurora and related space weather phenomena is more than just scientific interest. It's crucial for pragmatic reasons as well. Protecting our technological infrastructure requires an understanding of the ability to predict geomagnetic storms. However, the aurora and geomagnetic storms serve as a reminder that the Earth is not a standalone system. Our planet is always in contact with the Sun, is affected by solar activity, and is involved in cosmic processes that are much bigger than any human system. An obvious example of this link is the aurora, which serves as a constant reminder that we are a part of the global aurora. Although the northern lights, or aurora borealis, have been our main emphasis, it's important to keep in mind that the southern lights, or aurora auroralis, are also there. In the southern hemisphere, this behavior is essentially the same. The same places where the aurora borealis happens at northern latitudes are also where the aurora auroralis appear at southern latitudes. Antarctica, southern Australia, New Zealand, southern Chile and southern Argentina are the most popular places to see the aurora auroralis. The same solar wind disruptions cause the auroras at both poles, and they happen at the same time. The aurora auroralis are dancing over the Antarctic night at the same time as the aurora borealis is during a geomagnetic storm. The Antarctic and the extreme south are less populated than the Arctic and subarctic regions because there are less watchers of the southern aurora. It is less commonly documented and less well known. The southern lights, however, are just as stunning for those who have made the journey to witness them. An aurora viewed from the top of the planet is just as amazing as one viewed from the bottom. Aurora Science's future. Research on aurora is still developing. Improved equipment on new satellites are being launched to study the particles involved in auroral processes and the magnetosphere. Data is still being collected by ground-based equipment. In order to explain aspects of auroral displays that don't yet easily fit into pre-existing models, researchers are constantly coming up with new theories. Understanding the aurora's small-scale structures is one frontier. Although there are lower-size structures, the majority of observations concentrate on big-scale characteristics, such as arcs, rays, and bands. What physical processes result in these fine-scale characteristics? What connection do they have to the large-scale operations? We are starting to answer these queries. Understanding the intricate mechanics underlying particle acceleration is another frontier. Although we are aware that particles are accelerated to great energy, research into the precise mechanisms and processes responsible for this acceleration is currently ongoing. Under some circumstances, other mechanisms could predominate. Gaining insight into these processes would enhance our general comprehension of plasma physics and the magnetosphere. Understanding how the magnetosphere and atmosphere are coupled is a third frontier. During the aurora, energy is being deposited in the upper atmosphere of the 40s. However, what impact does this energy have on the atmosphere? Does it affect the flow of air? Does the weather change as a result? We are starting to investigate these questions. The tales we have told for generations. People have made up tales about the aurora. Some of the indigenous stories have been covered. A story told by the Inuit about spirits playing with a walrus's head. Whistling at the lights was a smy caution. The aurora has its own myths in Western scientific culture. The current scientific narrative about charged particles colliding with air atoms, the magnetosphere, the solar wind, and the aurora is also a fiction. We use this anecdote to clarify a previously enigmatic concept. It's a testable narrative that can be confirmed by experimentation and observation, and it keeps changing as new information becomes available. However, it remains a narrative, an effort to use words and ideas to explain a natural occurrence. The ability of the scientific story and the traditional stories to coexist is amazing. The physics behind the aurora can be understood. How particles in the solar wind interact with the magnetic field of Earth. How they feel AED by the display even after colliding with air atoms to produce light. The awe is not lessened by knowing the mechanism, knowing the scope of the procedures involved, if anything. Realizing that you're observing how the sun and Earth interact on a global scale. The sense of awe might be enhanced by realizing that what you're witnessing is a genuine event involving the release of immense forces. The darkness grows darker. We can believe that the night grows darker as we lie here and think about the aurora. If there was a display, it has dimmed. Overhead, the stars shine steadily, a river of far-off suns, the Milky Way arcs across the sky. As the night moves into its deepest hours, the period immediately before dawn, when the temperature is typically at its lowest, the frigid air gets colder. But the processes go on even during this silent time, during the darkest darkness. Particles of the solar wind are emanating from the sun somewhere. They're interacting with the Earth's magnetosphere somewhere. Photons of light are still being produced somewhere in the high atmosphere by the excitation and de-excitation of atomic states. You may not see the aurora right away. Even if the sky is calm and clear, the processes are taking place in the far north. This could mark the start of another auroral substorm. The faded arc might become bright once more. Rays could shoot up. As night falls into the hours after midnight, when the aurora is frequently at its most active, it may come alive once more. Alternatively, the night can be silent, with only the Milky Way and stars visible, and no aurora. This is also possible. Even in the auroral zone, an aurora does not appear every night. The solar wind might be weak at times. The magnetosphere can be stable at times. There are instances when the circumstances are just not right to create auroral activity that may be seen. Aurora hunters are waiting. The waiting has a certain feel about it. Waiting for the aurora bears some similarities to waiting for other erratic or uncommon natural occurrences. In a thunderstorm, waiting for lightning. Waiting for the ideal solar eclipse moment. Awaiting the sunset to produce striking hues. However, there is something unique about waiting for the aurora. In contrast to these other phenomena, it is not event-focused. There will eventually be a thunderstorm that ends. A solar eclipse occurs at a certain moment. While the aurora might emerge and disappear rather randomly, a sunset has a regular timetable. Either a lengthy wait or an instantaneous one is possible. The display may be brief or last for several hours. A specific mental state is produced by this unpredictability and the beauty of what you're waiting for. Naturally, there is hope and anticipation that the lights will come on. There is patience and the capacity to endure hours of waiting in frigid temperatures. A sort of calm acceptance is also there, letting yourself relax in the knowledge that you have no influence over the aurora and that it will act in its own way, regardless of your wishes. This contemplative component of aurora viewing is just as significant to many people as actually seeing the lights. The act of waiting, observing, or simply being there when standing in the Arctic night. In and of itself, this is valuable, regardless of whether the aurora is visible. The gift of silence. We are rarely still in the modern world. Most of the time, we are working, talking, eating, exercising, and consuming information. Even when we're sleeping, we may be using our devices in some form, such as watching screens, listening to podcasts or music, or waiting for the aurora in the Arctic night. You are in a motionless state. Your mind can be at ease, even if your body is frigid. You're not doing anything. Information is not being consumed by you. You're just waiting, watching, and being present. It serves as a reminder that we are a part of bigger rhythms and patterns. These enormous cycles serve as the backdrop for our individual lives, troubles, and accomplishments. Our unique experiences are not diminished in any way by this. Instead, it puts them in context. It serves as a reminder that we belong to something far bigger than ourselves, the hues of feeling. Different aurora colors elicit different reactions in different people. Some claim that they feel tranquil and at peace when they see the green aurora. The red, which is more infrequent and has an unearthly feel, moves others more profoundly. However, the blue and purple, which might seem almost alien, have the greatest effect on others. The emotional reaction that should be evoked by various hues may not differ objectively. However, people regularly report feeling distinct emotions when exposed to different hues. Maybe because the red and blue auroras are so uncommon, witnessing them feels like a unique experience, something more important. Or maybe there's a psychological component to the way we've been conditioned by art and society to identify certain hues with particular emotions. It has been said that the aurora's green is a healing, serene, and tranquil green. Perhaps because it is brilliant and originates from within the sky rather than reflecting sunlight, it differs from the greens of nature, such as grass or leaves. People have characterized the aurora's crimson as enigmatic, menacing, and mystical. It has been said that purple and blue are weird, unearthly, and alien. All of these descriptors are subjective, of course. Simply put, the aurora is light with specific wavelengths. Regardless of our interpretation, however, the feeling of beauty and emotion that comes with seeing the aurora is true. The quiet speaks for itself. The great silence of viewing the aurora in the Arctic night has been discussed. However, silence is not an easy thing. Silence comes in several forms. The silence that results from the lack of sound is one of them. The actual acoustic quiet of a place remote from human civilization, devoid of vehicles, equipment, and people. This is the simplest definition of silence. However, there is also what could be referred to as emotional quiet. The quiet that accompanies serenity, tranquility, and the lack of inner chatter. Even if they could theoretically hear their own breathing, the crunch of snow beneath their feet, or even the distant wind, a person standing in the Arctic night might manage to achieve this kind of silence. This emotional quiet is influenced by the aurora itself. Few other encounters have the ability to calm the mind like its beauty and mystery. Self-judgment, work pressures, social fears, and other common worries recede into the background. All that's left are awareness, appreciation, presence, and the feeling of amazement. The aurora experience is significantly impacted by the cold. Being outside is necessary to see the aurora, yet being in the Arctic means being extremely cold. The temperature could be as low as -20, -30, or -40 degrees Celsius. It is a physical fact that it is cold. It's not comfy. It calls for specific attire. Staying outside for an extended period of time poses serious risks. Attention must be paid to the cold. You have to take care of it, must respect it and control it. The sensation of seeing the aurora, however, also seems to be enhanced by the cold. Maybe it's because the cold's misery keeps you grounded and in the here and now. Being cold prevents you from dozing off or zoning out. Your body reminds you of your physical condition all the time. Or maybe the frigid surroundings and the lovely warm-toned hues of the aurora produce a sort of contrast that benefits both. Against the backdrop of the chilly night, the aurora blooms even brighter. The icy snow, the dazzling stars, and the frigid air. Each of these acts as a framing to enhance the aurora's brightness. Additionally, the event seems to have more meaning because of the courage to withstand the cold. You have made the decision to stand in an unforgiving setting and cause yourself discomfort in order to observe this natural occurrence. This decision and this dedication give the event a psychological weight that enhances its significance and memorability. Simplicity as a gift. Experience is frequently filtered in our contemporary society. We use screens to experience the world. We take in works of literature, music, and art that have been refined, edited, and curated. Through meticulously planned tourist experiences, we get to experience travel. Seldom do we come across unadulterated, unfiltered reality. Aurora viewing is a unique experience. You're not looking at a picture or a video. A curated or altered version is not what you're seeing. You're witnessing the phenomenon firsthand, just as it is. This has a certain simplicity about it. What it is the aurora. It's not attempting to be pretty. Physical processes have created a simple beauty. It's not attempting to convey a certain message. It's just a natural phenomenon called an aurora. This simplicity and directness can have enormous effects. It provides some respite from the continual curation and mediation that permeate so much of contemporary life. The darkness, the cold, the lights in the sky, and the emptiness above. It's just you. The aurora can be seen between 100 and 300 kilometers above the ground. Since you can't drive, fly, or climb to the aurora, it's practically out of reach for any person. It's something you see from below, something that occurs above you. This adds to a certain aspect of the experience, a feeling of being in the presence of something enormous, something that is far bigger than humans. Across several time zones, the lights might stretch for hundreds of kilometers. The entire magnetosphere is involved in the processes that create them, which take place on thousands of kilometers. You are witnessing something that is larger than man when you gaze up at the aurora. It's not intimate and little. It's not the same as viewing a sculpture or painting. It is all-pervasive and all-encompassing, sometimes referred to as the sublime. This vastness can evoke a certain emotional reaction. Beauty and the sublime are not the same thing. Harmony, proportion, and control are frequently key components of beauty. The sublime is about being overwhelmed by something so much bigger than yourself that it humbles you. It's about grandeur. By creating this feeling of the sublime, the aurora serves as a reminder of our position within Name, the greater scheme of things. We're not big. We are only here temporarily. Regardless of our personal worries, we are a part of something bigger and ongoing. Light's mathematical properties. The physics of the aurora's production has been covered. When particles from the solar wind collide with atoms in the atmosphere, light is released. However, the aurora also has a mathematical component, a geometry that is worth considering. There is a specific geometry to the magnetic field lines that direct charged particles toward the polar regions. They form a funnel-like structure as they converge near the poles. The geometry of Earth's magnetic field and the characteristics of the solar wind can be used to estimate the size and shape of the auroral oval, which is the ring of auroral activity surrounding each pole. Each of the aurora's distinct features, the arcs, rays, and curtains, has a unique geometry. The geometry of the field lines there is revealed by the rays, which are usually aligned with the direction of the local magnetic field. Areas where a large number of particles are precipitating into the atmosphere are shown by the arcs. Waves and instabilities in the plasma environment are reflected by the curtains and drapes. The aurora can be thought of as a visual representation of mathematical structures that are invisible. Although the magnetic field lines are invisible, the aurora makes them visible. Although the waves and instabilities in the plasma environment are invisible, they cause the aurora to display visual patterns. The aurora is using light to write mathematical symbols across the sky, the cadence of anticipation. Waiting for the aurora has a certain cadence. Anticipation grows as the evening draws to a close and the hours after midnight approach. Aurora activity is most likely to occur during this period. Maybe it will show up now, if it hasn't already. Every second that goes by might mark the start of the exhibition or the arc's illumination. A specific psychological state, one of acceptance and expectation, is produced as a result. While you're hoping for the aurora, you're also embracing the possibility that it won't show up. You pay attention, but not in a panic. You don't have any expectations, but you're willing to wait. The clock advances toward the most likely moment. Maybe you notice a slight glow, a brightening of the horizon, or the first signs of activity. You may experience an increase in heart rate. It may be this. However, it could also be a false alert, a momentary illumination that doesn't turn into a real display. Or the night may be silent. The hours fly by. The most likely moment comes and goes. No aurora is seen. However, you have been there. You have been observing. You have participated in the process. It is not a failure if there is no aurora. You were present, you observed, you waited. That's sufficient. The trip north. A lot of individuals feel compelled to go north, especially to witness the aurora. Aurora experiences are available on certain excursions and packages. People schedule vacation time, spend money they may have been saving, and take trips to far-flung northern destinations like Alaska, Canada, Scandinavia, Iceland, and Siberia. There is a sense of pilgrimage about this trip north. People go to see a certain item, something they've heard about, something they've imagined, something that appeals to them. To enjoy this experience, they are exerting themselves and investing resources. The experience itself includes the travel. The gravity of what lies ahead is enhanced by the lengthy voyage, the entry into unknown country, and the landing in a site of extremes. People are already in a certain mental condition when they travel to the far north and go outside to search for the aurora. They are open to the experience, alert, and responsive. The experience of seeing the aurora becomes life-changing for some people. The experience of visiting a far-off place, facing a harsh climate, and taking in this magnitude of natural beauty. It has the power to transform people's viewpoints, generate fresh ideas, and motivate them to make lifestyle adjustments. The warmth returned. The night eventually comes to an end. Either the night has been peaceful, or the aurora display has happened and subsided. In any case, you will soon find refuge, warmth, and the conveniences of human society again. It's a dramatic change from the Arctic night to warmth and protection. It's a striking contrast. You enter a heated area after being in the bitterly cold outside. You enter areas with sounds and bustle after leaving the quiet and calm of the night. You return to the intricacy and bustle of everyday life after experiencing the aurora's immensity, darkness, and simplicity. The change may seem abrupt. You may find yourself hesitant to leave the night, unwilling to return to the everyday world, and reluctant to come back inside. The coziness and warmth seem inviting at the same time. Your face and icy hands warm up. Your weary body unwinds. Both literally and figuratively, you start to thaw. The memories decline. Almost instantly, the aurora's memory starts to wane. If the display was bright and colourful, the recollection is relatively clear for some time. However, even intense sensations pass. Details become unclear. It gets more difficult to remember the precise hues. The beam's precise motions become hazy. The recollection may be even more fleeting if you saw merely a dim display or if you waited and saw nothing. Did you notice the horizon's little brightening? Did it truly look as lovely as you recall? Were the hues truly that vivid? The memory can be preserved with the aid of photography. Colours and subtleties that the human eye might overlook or forget are captured in a photograph. However, a picture also takes the place of the memory. As time passes, the picture may become more vivid in your mind than the actual sensation of watching the lights while standing in the cold. Memory loss is normal and sometimes even required. We might feel overpowered if our experiences were preserved in perfect clarity forever. We may assimilate the experience, comprehend its meaning for us, and go on thanks to the fading. This fading, however, has a poignant quality that invites us to be really present during the actual event. Only the memory of the encounter, which eventually fades, may be preserved. The impression of having seen something large and lovely is what is still evident, the feeling that something bigger than yourself has touched you. The sky's calendar. The far northern sky is home to a variety of phenomena, including the aurora. At high latitudes, the night sky presents a series of phenomena that span longer time scales and the seasons. When the polar night peaks in the deepest winter, there is complete and lasting darkness. The brightness of the stars is astounding. The constellations are not the same as those seen by someone at a lower latitude. The well-known temperate latitude constellations give way to the perpetually rotating circumpolar constellations, which are made up of stars that circle the pole throughout the night. The sun's light starts to return as winter gives way to spring. The darkness lasts less time. At midday, the twilight progressively gets brighter. The sky is no longer entirely dark, making the stars less visible. However, another phenomenon is now conceivable. In addition to creating aurora conditions, the spring equinox also produces a specific type of light. The midnight sun marks the arrival of summer. The sun doesn't set for weeks. The darkness never comes back. This can be weeks or months of non-stop daylight at places far enough north. The aurora continues to occur. The precipitation of particles into the atmosphere continues. Light is still being emitted by excited oxygen and nitrogen atoms, but it is invisible since daylight has blotted it out. Even when it's not seen, the aurora is constantly present. Then comes fall. The daytime hours get shorter. The darkness returns when the sun sets again. Another period of increased aurora activity occurs around the autumnal equinox. With its extended darkness and frequent aurora displays, winter is coming around again. There is no end to this loop. There are seasonal patterns in the sky. The sun rises, sets, hovers over the horizon, or vanishes completely. The stately wheel of the stars rotates overhead. Seasons and the solar cycle cause the aurora to come and go. Its consistency changes. The aurora's consistency is one feature that merits consideration. For thousands of years, people have been observing the aurora. People in the past made up stories about it. People in the Middle Ages wrote it down. People today use advanced instruments to observe it. The aurora has existed throughout human history and is a common occurrence in the far north. We now have a different understanding of the aurora. The technology we use to observe it has evolved. Although we have become better at predicting it, the phenomenon itself has remained essentially constant. The aurora is created today by the same physical mechanisms that created it a millennium ago. In a way, this consistency is consoling. A lot of things change. Civilizations are born and die. Landscapes change. Species become extinct. As technology develops, it becomes outdated. However, the aurora continues. It serves as a reminder that there are natural rhythms and processes that persist despite the perpetual flux and change of human events. In this context, the aurora is timeless, not in the sense that it exists beyond of time. The aurora is timeless in the sense that it is old, constant, and enduring, even if it does exist in time, happen at certain times, and change over seconds, minutes, and hours. There is an unbroken chain connecting tonight's aurora to those that happened thousands of years ago. The humility of comprehension, the science behind the aurora, the solar wind, the magnetosphere, charged particles, and collisions with atmosphere atoms have all been covered. All of this can be explained by modern science. We know the physics. We are able to forecast the likelihood of seeing the aurora. We can use advanced devices to measure its qualities. However, the feeling of mystery persists even after the mechanism is understood. It deepens it in certain ways. The more we learn about the aurora's functioning, the more we realize how extensive and intricate the processes are. As our knowledge of the magnetosphere grows, we become more aware of how much is still unknown, improve our ability to monitor auroral characteristics, and find more patterns and traits that defy accepted hypotheses. Knowledge is provided by science, but it is not omniscience. Although it offers explanations, they are not comprehensive. When science solves some riddles, it uncovers more complex ones. This is how all scientific knowledge is derived. It both broadens and reveals the boundaries of our current understanding. We are beautifully reminded of this by the aurora. We know a great deal about it. However, it is still unclear, complicated, and mysterious. The wonder is not diminished by the science. In fact, it makes things better by bringing to light the complexity of the situation. Darkness is a gift. Darkness has become something we shun in today's society. We light up our cities. We illuminate our houses. Screens and flashlights are the lights we take with us. True darkness is rarely experienced by us. True darkness can be found in the extreme north, particularly in the winter. The kind of darkness that predated electric light and modern civilization. At the very least, the fear of this darkness immediately subsides when you realize there is nothing to be afraid of. The lack of light is what makes the darkness what it is. In a sense, this darkness is a blessing. The darkness of the Arctic night provides solace in a world when light, knowledge, and stimulation are all around us. It provides a return to the more primitive state in which we spent the majority of our evolutionary history as humans. The stars shine brighter in the darkness. The aurora is visible because of the darkness. There is a certain tranquility in the expanse and simplicity of the darkness. In the far north, winter ends and springtime begins in a different way. The days are either very short at somewhat lower latitudes or non-existent during the polar night in deep winter. Every day gets darker than the last. It gets colder. The surroundings get more harsh. However, winter ultimately reaches a turning point. The winter solstice is followed by the shortest day, and the days start to become longer after that. The daily arc of the sun starts to ascend. The shadows start to fade. The significance of this pivotal moment extends beyond the calendar itself. The winter solstice and the ensuing progressive lengthening of the days are a turning point in both spiritual and psychological development. The winter's worst is over. The arrival of spring is imminent. During this time, the aurora persists. It stays by your side during the protracted darkness. Additionally, it gets harder to see the aurora as spring draws near and the nighttime gets shorter. It's because the sky isn't dark enough to see it anymore, not because it's not happening. The aurora is obscured by daylight by the time genuine spring arrives and the sun starts to stay above the horizon for long stretches of time. As fall and the long darkness return, the companion of the long winter disappears from view. A condition of preparedness, a sense of constant preparedness develops in people who either reside in the aurora zone or visit it to witness it. There is always a chance of seeing the aurora on clear nights during the dark season. As a result, people become more prepared and willing to go outside whenever they want to glance up and examine the night sky. Many who feel this readiness say it's truly restorative, despite the fact that it may appear draining. It helps you stay in touch with nature. You become more aware of the stars, the night sky, the weather, and the minute clues that could point to auroral activity. It produces an alertness that is distinct from the tense vigilance of contemporary living. This vigilance is laid back and transparent, an openness to being taken aback by nature. The indigenous witness of the world. Indigenous peoples in the Arctic witnessed the aurora before science provided us with spectrographs and satellites, before we could quantify the solar wind or examine spectral lines. They had a deep understanding of the phenomenon, but not the mechanism. They integrated it into their worldview, lived with it, and watched it frequently. The Inupiat, Upupik, Kalalit, and Inuit peoples, among others, created stories about the aurora that mirrored their surroundings and the natural beauty they witnessed. The rugged Arctic terrain, the protracted darkness, and the need for close night sky observation for forecasting and navigation. Their perception of the lights was influenced by all of this. Spirits playing with a walrus head is a clear and distinct image. Something authentic is captured. The feeling of amusement, play, and aimless movement. The aurora appears to move like though playing a game, as though it is motivated by forces other than simple physics. Of course, physics is the driving force behind the game, the way the magnetosphere and solar wind interact. But it's a fitting metaphor. The aurora has a whimsical character, a motion that seems to have no clear aim, and it urges spectators to see it as play. Danger was highlighted in other indigenous views. Certain Sami customs cautioned against the aurora, implying that it should not be taken lightly. There is truth to this as well. Massive energies from solar and planetary processes are manifested in the aurora. People on the ground are not in danger from the aurora itself, but the processes that underlie it are intense and energetic on their scale. These conventional understandings weren't outdated or inaccurate. They were highly advanced methods of knowledge encoding. The Sami and Inuit were aware of the best times to see the aurora. They were able to identify several kinds of auroral displays. They realized that there were correlations between the aurora and other occurrences, such as the weather, animal migration patterns, or the yearly cycle. This knowledge was encoded in their stories so that it could be passed down orally from one generation to the next. These old understandings have not been rendered obsolete by modern science. Instead, they have been strengthened and broadened by science. We now know that there is a connection between cycles and the aurora. Seasonal cycles, daily cycles, the sun's 27-day rotation, and the 11-year solar cycle. We know that the upper atmosphere is impacted by auroral activity in ways that could affect the weather. Even if the impacts are slight, we are able to appreciate the wisdom ingrained in classic storytelling while also fully comprehending the mechanics. The medieval understanding in Europe. European observers used the frameworks at their disposal to interpret the aurora when they first became aware of it, especially as exploration and colonization led Europeans to higher northern latitudes. The aurora was frequently interpreted as a celestial omen during the Middle Ages, a sign from God or the heavens about matters on Earth. Auroras are occasionally mentioned in medieval and Renaissance European chronicles, frequently in connection with noteworthy occurrences. Alongside accounts of war, plague, political unrest, or a monarch's death, there may be an especially vivid aurora. This was a reflection of a worldview that held that the heavens and earth were intertwined, and that heavenly signs conveyed information about occurrences on earth. The lack of light is what makes the darkness what it is. In a sense, this darkness is a blessing. The darkness of the Arctic night provides solace in a world when light, knowledge, and stimulation are all around us. It provides a return to the more primitive state in which we spent the majority of our evolutionary history as humans. The stars shine brighter in the darkness. The aurora is visible because of the darkness. There is a certain tranquility in the expanse and simplicity of the darkness. In the far north, winter ends and springtime begins in a different way. The days are either very short at somewhat lower latitudes or non-existent during the polar night in deep winter. Every day gets darker than the last. It gets colder. The surroundings get more harsh. However, winter ultimately reaches a turning point. The winter solstice is followed by the shortest day, and the days start to become longer after that. The daily arc of the sun starts to ascend. The shadows start to fade. The significance of this pivotal moment extends beyond the calendar itself. The winter solstice and the ensuing progressive lengthening of the days are a turning point in both spiritual and psychological development. The winter's worst is over. The arrival of spring is imminent. During this time, the aurora persists. It stays by your side during the protracted darkness. Additionally, it gets harder to see the aurora as spring draws near and the nighttime gets shorter. It's because the sky isn't dark enough to see it anymore, not because it's not happening. The aurora is obscured by daylight by the time genuine spring arrives and the sun starts to stay above the horizon for long stretches of time. As fall and the long darkness return, the companion of the long winter disappears from view. A condition of preparedness. A sense of constant preparedness develops in people who either reside in the aurora zone or visit it to witness it. There is always a chance of seeing the aurora on clear nights during the dark season. As a result, people become more prepared and willing to go outside whenever they want to glance up and examine the night sky. Many who feel this readiness say it's truly restorative, despite the fact that it may appear draining. It helps you stay in touch with nature. You become more aware of the stars, the night sky, the weather, and the minute clues that could point to auroral activity. It produces an alertness that is distinct from the tense vigilance of contemporary living. This vigilance is laid back and transparent, an openness to being taken aback by nature, the indigenous witness of the world. Indigenous peoples in the Arctic witnessed the aurora before science provided us with spectrographs and satellites, before we could quantify the solar wind or examine spectral lines. They had a deep understanding of the phenomenon, but not the mechanism. They integrated it into their worldview, lived with it, and watched it frequently. The Inupiat, Upupik, Kalalit, and Inuit peoples, among others, created stories about the aurora that mirrored their surroundings and the natural beauty they witnessed. The rugged Arctic terrain, the protracted darkness, and the need for close night sky observation for forecasting and navigation. Their perception of the lights was influenced by all of this. Spirits playing with a walrus head is a clear and distinct image. Something authentic is captured. The feeling of amusement, play, and aimless movement. The aurora appears to move like though playing a game, as though it is motivated by forces other than simple physics. Of course, physics is the driving force behind the game, the way the magnetosphere and solar wind interact, but it's a fitting metaphor. The aurora has a whimsical character, a motion that seems to have no clear aim, and it urges spectators to see it as play. Danger was highlighted in other indigenous views. Certain Sami customs cautioned against the aurora, implying that it should not be taken lightly. There is truth to this as well. Massive energies from solar and planetary processes are manifested in the aurora. People on the ground are not in danger from the aurora itself, but the processes that underlie it are intense and energetic on their scale. These conventional understandings weren't outdated or inaccurate. They were highly advanced methods of knowledge encoding. The Sami and Inuit were aware of the best times to see the aurora. They were able to identify several kinds of auroral displays. They realized that there were correlations between the aurora and other occurrences, such as the weather, animal migration patterns, or the yearly cycle. This knowledge was encoded in their stories so that it could be passed down orally from one generation to the next. These old understandings have not been rendered obsolete by modern science. Instead, they have been strengthened and broadened by science. We now know that there is a connection between cycles and the aurora. Seasonal cycles, daily cycles, the sun's 27-day rotation, and the 11-year solar cycle. We know that the upper atmosphere is impacted by auroral activity in ways that could affect the weather. Even if the impacts are slight, we are able to appreciate the wisdom ingrained in classic storytelling while also fully comprehending the mechanics. The medieval understanding in Europe. European observers used the frameworks at their disposal to interpret the aurora when they first became aware of it, especially as exploration and colonization led Europeans to higher northern latitudes. The aurora was frequently interpreted as a celestial omen during the Middle Ages, a sign from God or the heavens about matters on earth. Auroras are occasionally mentioned in medieval and Renaissance European chronicles, frequently in connection with noteworthy occurrences. Alongside accounts of war, plague, political unrest, or a monarch's death, there may be an especially vivid aurora. This was a reflection of a worldview that held that the heavens and earth were intertwined and that heavenly signs conveyed information about occurrences on earth. We can identify this as a type of mistake. In reality, the aurora has little influence over or ability to foresee earthly events. However, it also reveals a crucial insight. Yes, there is a connection between the ground and the heavens. Rather than divine communication, we now comprehend this link in terms of magnetospheric physics. However, the basic realization that we are not alone and that cosmic events impact Earth is still true. As the science of electricity and magnetism progressed and researchers became more methodical in their studies, the scientific lighting and knowledge of the aurora gradually evolved throughout the 18th and 19th century. Scientists had a reasonably comprehensive understanding of the aurora's production by the early 20th century. When satellites were able to detect the solar wind and the magnetosphere directly during the space era, it was a major breakthrough. Suddenly, real measurements might be used to test the theoretical predictions. Observations from orbit could solve the issues that had remained unsolvable on the ground. The intricacy of the magnetosphere was one of the major insights gained from studying auroras in the space age. The magnetosphere is more than just a passive barrier that keeps the solar wind out. It is a dynamic system that is always changing, reacting to variations in the solar wind and exchanging particles and energy with the Earth's atmosphere and the solar wind. There are real-world applications for comprehending this. Solar-driven geomagnetic storms have the potential to harm satellites and interfere with electrical systems. Decades of research into the aurora and the magnetosphere have led to the development of modern space weather forecasting, which enables us to anticipate when such storms are likely to occur and adjust our technology accordingly. However, comprehension also has philosophical or spiritual ramifications. It serves as a reminder that we are not alone on Earth, that the sun, solar wind, and 4 magnetospheres are examples of foreign factors that continuously affect our Earth. We are a part of a larger, more interrelated whole, the aurora experience of today. Aurora viewing has become both more accessible and more mediated in the modern day. More accessible due to the easy availability of information on the internet regarding the best times and locations to view the aurora. We can experience the aurora through photos, films, and online streams in addition to or instead of seeing it in person, making it more mediated. For the expert aurora photographer, the process entails monitoring forecasts, assessing weather trends, setting up gear, braving the cold, and trying to picture the lights. The images can be breathtaking, bringing out subtleties and hues that the human eye might overlook. However, the photos also serve as a stand-in for the actual experience. The experience is more carefully planned for the visitor on an aurora tour. In addition to managing the logistics, the tour operator offers the visitor a degree of comfort, heated tours, possibly hot beverages, and process guidance. The experience is more accessible, less impromptu, and less reliant on prior knowledge and planning. The experience is a part of everyday life for the Aurora Zone residents. There is no need for extra preparation or travel because the aurora is a common occurrence. It has an informal familiarity. However, even those who have witnessed the aurora hundreds of times say it never becomes monotonous. All of these ways of seeing the aurora are legitimate. Each offers a unique contribution. The picture captures a moment. The guided tour fosters social interaction and education. Immediacy and a personal encounter are provided by the immediate experience. Colors from different cultures. The various hues of the aurora have elicited varied reactions in various cultures. In many traditions, the predominant hue green has been associated with healing or tranquility, It has frequently been assumed that the rarer red is more sinister or enigmatic. The crimson aurora was seen as very important in some traditions. The northern location and cosmic significance of the aurora are reflected in the Japanese phrase Kitagataka Zeno Kukai Mono, or more often Kitakazake Nukai. However, traditional Japanese legends placed a strong emphasis on the color red, viewing red auroras as especially significant or menacing. The aurora's colors were occasionally interpreted using fire as a symbol in Scandinavian and other European traditions. Red auroras were interpreted as fire from the sky, a sign or a portent. This demonstrated the visual resemblance between fire and the red aurora, but it also conveyed something of the aurora's dynamic quality, activity, and vitality. The aurora was less common in Polynesian traditions, but it was infrequently recorded in historical accounts, especially when the aurora was visible from Polynesian places during times of extraordinary solar activity that brought the auroral oval to lower latitudes than usual. It became part of mythology and stories about navigation. The fact that auroral interpretation is regarded seriously is a culturally universal feature. The aurora is seen as important by all cultures, regardless of how they interpret it. It is not regarded as a common or incidental occurrence. It is integrated into the physics of magnetospheric storms, spiritual comprehension, cosmology, and the cultural story of meaning. We need to comprehend the mechanisms underlying the aurora in order to fully comprehend it. There is variation in the solar wind that emanates from the sun. It fluctuates in temperature, magnetic field strength, velocity, and density. A coronal mass ejection CME can shoot billions of tons of plasma at up to hundreds of kilometers per second toward Earth when it bursts from the sun. The magnetosphere reacts when this disruption reaches the Earth's magnetosphere. On the side that faces the sun, the magnetic field is squeezed. On the night side, the magnetosphere's tail elongates and distorts. With so much stored energy, this structure is unstable. Magnetic reconnection is one of the methods that eventually relieve the instability. The stored energy is released when magnetic field lines reunite into a lower energy form. Particles have a high rate of acceleration. The magnetic field lines direct these particles in the direction of the polar regions. The energy of the solar wind is transformed into energetic particles that can travel to the upper atmosphere and create the aurora by this process, which is incredibly effective. A large quantity of energy is being released and directed toward the upper atmosphere if the disturbance is really powerful and causes intense auroras. This energy intake causes a reaction in the high atmosphere. The particles collide with atoms and molecules in the atmosphere to deposit their energy. As the atmosphere warms, winds form. The upper atmosphere's structure is disrupted. It's interesting to note that the aurora itself is one of the ways this energy is released or transformed into different forms. The aurora's light is a representation of energy that has been transformed from particle kinetic energy into photons. Thus, the aurora is actually a means by which the upper atmosphere gets rid of the energy that the solar wind and magnetosphere provide. This energy processing never stops. The aurora is happening every night, even when the geomagnetic conditions are calm. There is a loss of energy. Under disrupted conditions, the system is operating. The rate of dissipation of energy increases. The aurora is being used to handle more electricity. The aurora becomes brighter, the change in observers. A lot of people say that seeing a bright aurora up close is a life-changing event, not in the sense that, although it occasionally does, it results in significant changes in personality or life path. Instead, it's transformative in the sense that it offers a fresh perspective on the world and one's role in it. After seeing the aurora, people frequently report feeling both bigger and smaller at the same time. Smaller because humans can be humbled by facing the immensity of the universe and the force of uncontrollable natural processes. Greater because we can feel more linked to cosmic processes and have a greater sense of possibilities when we see something so large and lovely. According to others, seeing the aurora makes priorities clear. In the vastness of the galaxy, the problems and anxieties that typically consume their minds, financial, professional, and social, seem less significant and urgent. It becomes evident what is important. According to other people, seeing the aurora strengthens their bond with nature. They feel closer to nature in general after standing beneath the aurora and sensing its presence. They focus more on the sky, the weather, seasonal variations, and natural patterns. Some claim that seeing the aurora is associated with mystical or spiritual experiences. They sense that they are a part of something greater, something holy, maybe something that is beyond our normal comprehension. It's still unclear if this is a subjective interpretation that spectators give to the aurora, or if it represents something actually true about it. We are unable to confirm the presence of spiritual or transcendent qualities from a scientific perspective. We can accept, however, that people have these experiences and that they hold significance for them. Magnetism's poetics. We might consider the poetry of magnetism itself when we consider the aurora and its intricate mechanisms. Despite being invisible, magnetic fields have a significant impact on how charged particles behave. The way electric motors work, how compasses work, and how the solar wind and magnetosphere behave are all impacted by these unseen forces. In a way, the magnetic field is made visible by the aurora. Light is created when particles traveling along magnetic field lines hit with air atoms. The magnetic field lines themselves are invisible. The magnetic field lines are traced by the light. The magnetic field that is made visible is called the aurora. The aurora is a stunning illustration of how invisible forces shape visible phenomena in this sense. These unseen structures, electromagnetic fields, gravitational fields, quantum fields, and underlying subatomic particles are all around us. The behavior of the visible world is determined by these unseen structures. The aurora serves as a reminder. A phenomenon that presents structure and force as light and color has a lyrical quality that makes the invisible visible. The aurora's ability to change the theoretical into the visual and the abstract into the concrete is what makes it poetic, not any meaning it may convey. The archive of night skies. For a brief period, picture yourself as an astronomer, a researcher who studies the environment in space around Earth. You spend your nights examining measurements from ground-based instruments, satellite data and images and videos of auroras taken by global observers. You're contributing to a knowledge base, a huge compilation of decades' worth of observations. This archive is more than just a compilation of information. The behavior of the sun, the aurora, and the magnetosphere is chronicled and documented in this historical record. Patterns can be seen in this archive. The archive contains information about the 11-year solar cycle. We are able to recognize seasonal differences. The long-term patterns in solar activity are discernible. Beyond that, however, there are surprises in the archive. Some auroras exhibit odd characteristics that defy our comprehension and don't follow the typical patterns. These revelations motivate more study. They challenge what we already know. They serve as a reminder that the aurora still has mysteries in spite of our advanced technology and the amount of data we have collected. There is a specific type of expertise that emerges for someone who studies the aurora, spending years making observations and deciphering patterns. It involves more than only understanding the physics. By observing hundreds or thousands of auroras, one can gain an instinctive understanding of what a typical aurora looks like, what patterns are prevalent, and what characteristics are unique. It is possible for a skilled aurora researcher to spot something out of the ordinary in a single shot, can spot patterns that would be far more difficult for a novice observer to spot. Deep engagement, time spent with a phenomenon, and building a relationship with it are the sources of this type of knowledge. The global stations for observing and waiting. There are places devoted to studying and observing aurora. Some are significant research facilities run by government organizations or academic institutions. Others, who might be amateur observers keeping devices in far-off places, are more humble. A planetary science institute in Tromsø, Norway, has equipment specifically designed to study the aurora. The University of Alaska has a large collection of auroral observing equipment in Fairbanks, Alaska. A geophysical observatory with decades of continuous measurement is located in Sodangila, Finland. There are more stations in Siberia, Antarctica, and the Canadian North, all of which add to our knowledge. These stations serve as more than just data collection locations. Additionally, there are locations where people congregate to view, converse, and enjoy the aurora. These stations have a culture, a feeling of collective dedication to comprehending a phenomenon. While some of these stations have been in operation for generations, others have been in operation for decades. Early 20th century observations prepared the way for subsequent studies. The following generation of scientists, who employed satellites to measure what earlier generations could only observe from the ground, were trained by the scientists who worked at these stations in the 1960 and 1972 periods. The concept of this continuity has a certain poignancy. Scientists from all over the world and from all eras worked on the same topic, adding to the gradual body of knowledge. Numerous eyes have seen the aurora, and innumerable instruments have measured it and studied it over innumerable hours of work. But it's still pretty much the same thing, happening night after night in the far north. Whether or not someone is viewing or studying it, it is still lovely and intricate. Colors that are invisible to us. The colors that are visible to the human eye have been covered. The blue, purple, red, and green. However, the spectrum of light emitted by the aurora is wider than what our eyes can detect. During powerful displays, UV light is released. Infrared light is present. X-rays and other high-energy radiations are among them. Auroras that seem significantly different in ultraviolet light than in visible light have been seen by satellites fitted with UV sensors. The thermal traces of the aurora, which demonstrate the heating of the upper atmosphere, are revealed by instruments that detect infrared radiation. High-energy processes are seen during the strongest geomagnetic storms, according to X-ray measurements. This serves as a reminder that although our senses are amazing and enough for getting by in daily life, they only offer a limited view of the entire world. Although the visible aurora is stunning, it only represents a small portion of the true phenomenon. If we could see every wavelength at once, the complete aurora would be much more complicated and detailed than what our eyes can see. In a symbolic sense, a large portion of reality is like this. We only see a little portion of the reality. A lot of things are still invisible to us and can only be seen using tools that broaden our senses. In visible light, the aurora resembles the visible portion of an iceberg. Even if it is not visible to us, it is nevertheless very real. The observer's isolation, When someone ventures out into the Arctic night to observe the aurora, they frequently experience a deep sense of isolation. Even if you're in a tour group or there are other people around, you still feel like you're experiencing the phenomenon alone. Regardless of other observers, each person viewing the aurora is alone themselves. Some people may find this isolation uncomfortable. The huge, empty terrain, the cold, the darkness, and the existence of something so big, strong, and unconcerned with human issues. This combination creates a sort of existential discomfort for certain people. Others are quite happy to be alone. Standing alone in the Arctic night under the aurora provides a unique kind of respite in a world when we are virtually never truly alone and are almost always linked to others via technology. It's a return to solitude, not as isolation, but as a state of being that evolved with people and has been completely eradicated by modern life. The characteristics of an aurora seen alone differ from those of an aurora seen with others. There is communication, a shared experience, and a collective reaction in a group. When one is alone, the experience is wholly internal. The lights, your thoughts, and the great galaxy above are all alone with you. The cadence of getting ready for people who go north, especially to watch the aurora. The experience has a certain cadence. The planning stage comes first. Researching destinations, making travel arrangements, setting up gear, and monitoring forecasts. This stage may take weeks or months to complete. The arrival in the north follows. The intense cold, the darkness, the endless daylight, or the new surroundings all require adjustment. The scenery is very different from what most people are used to if you visit in the summer. A day or several days may pass during the arrival period. The observing stage follows. You may spend days or weeks observing the night sky if you have scheduled a multi-day aurora expedition. You get into a pattern of napping during the day, staying up at night, checking the forecast, going outdoors to observe, waiting and watching, maybe even catching a glimpse of the aurora. We have talked a lot about the phase of aurora viewing for those who happen to see it during this period. There is the acceptance phase for people who don't see it in spite of the wait. Accepting the potential that we may not see the lights on this particular excursion. However, after attempting and exerting effort, the phase of leaving begins. You take the memory of the event or the endeavor with you when you leave the north and resume your regular life. Locals have a different rhythm. They do not come and go. When the season of darkness comes, they are always prepared. The northern sky is always dark in places above the Arctic Circle during the season of light, when the aurora is perpetually absent. The sun doesn't rise in the winter. Every day of the year the sky is gloomy. This has a specific psychological impact. Constant darkness can be confusing, have an impact on mood, and necessitate adaptation. However, there are also special opportunities presented by this ongoing gloom. It's always dark in the sky. It is possible to make observations at any moment. The aurora may be observed at any time of day if it is active. This is perfect for aurora researchers. It can be a little confusing for visitors. There is only perpetual night and no discernible daylight rhythm. This is not the case at somewhat lower latitudes. Though it never completely sets or rises, the sun rounds the horizon instead of rising. During the alleged daytime hours, the sky is at twilight, and during the said nighttime, it is dark. This creates a lovely but slightly surreal world of perpetual twilight. The seasons shift more slowly further south. The winter months still provide protracted darkness, but not constant darkness, in areas around 60° north, such as southern Alaska, southern Canada, and southern Scandinavia. There is still a daylight cycle in mid-winter, albeit a compressed one, even though the sun may only be over the horizon for a few hours at midday. Different experiences are produced by these various latitudes. The longest aurora season and the darkest darkness can be found in the far north. The aurora season is shorter in the lower latitudes, but the daylight cycle is more recognizable, traveling south. The aurora becomes less often as we move from the Arctic areas into lower latitudes. It's possible for someone who lives in Boston, Seattle, or London to never see the aurora. Alternatively, people might witness it once during a really powerful geomagnetic storm and never forget it. The uniqueness is enhanced by the rarity. Even after seeing the aurora hundreds of times a year, a Fairbanks resident may still find it to be stunning. However, a Boston resident who witnesses an aurora once in their lifetime considers it a remarkable occurrence, something to talk about and remember. A trade-off exists. Perhaps there is less of a sense of great occasion among the Arctic observers, but they are familiar and frequent. The in-depth knowledge that comes from frequent observation may be lost on the remote observers, despite their rarity and intensity of experience. The aurora is more appealing to certain people because of this distance. It becomes into something they have to actively seek for, something they must travel for, and something that doesn't just happen to them. Part of the experience is the pursuit. Historical documents from before the invention of contemporary tools and satellites. Human observations, chronicles, manuscripts, and historical records from different cultures were the only sources of information about aurora activity. These sources reported auroras, especially the bright ones that were impossible to miss. Chinese astronomers documented everything in great detail. Auroras were recorded by European chroniclers. In order to comprehend long-term trends in solar activity, researchers have examined these historical records. In accordance with our knowledge of solar cycles, the records display times of high and low aurora activity. There are also anomalies and exceptions in the historical records. There are reports of auroras that were so intense that they could be seen throughout the day. Auroras that, according to the testimonies, made loud sounds, and auroras with extraordinary colors. We can now confirm through different methods that some of these rare records match to periods of unusual solar activity. We are reminded by these ancient documents that the aurora is not a recent phenomenon. It has been observed by humans for thousands of years. Our current scientific knowledge has deepened the explanation. However, the phenomenon itself is as old as the atmosphere and magnetic field of Earth. Time passes while the dancing continues. Now, as you lie here thinking about the aurora, know that it is dancing over the Arctic. The dance is still going on in the far north right now, whether you're watching or not. Observers are not necessary for the aurora to occur. It takes place in places where no one is around, where no tools are used to measure it, and where the show takes place in total isolation in the vast Arctic wilderness. Possibly one of the most profound features of the aurora is this. The phenomenon does not necessitate a complete observer. It happens whether someone sees it or not. Whether or not anyone sees it, its beauty endures. Regardless of who is there to witness it, its grandeur endures. This applies to every natural occurrence. Regardless of who views them, the mountains are undoubtedly stunning. Whether somebody is looking or not, the waves in the ocean will still crash. Observation or no observation, the stars shine. However, it is frequently necessary to remind us that the world was not made for human observation. That meaning and beauty are present without regard to human consciousness. This reminder is effectively given by the aurora. It takes place somewhere that most people will never go. Occasionally, the majority of people will never observe with a certain disregard for human needs or wants. It just happens as a result of the universe's natural processes. The request. It is true if you have ever felt drawn to the north, to the aurora, or to the sensation of being under the lights, that yearning to see something large and wonderful, to go somewhere extreme, to have a first-hand look at nature. These are justifiable desires. A rich and satisfying existence does not require traveling to see the aurora. Many individuals have incredibly fulfilling lives without ever seeing it. However, the attraction to the aurora is genuine for some people. The idea of standing in the Arctic night under the flickering lights stirs something deep inside of some people. Perhaps you will travel north one day if you sense this call, if the aurora narrative resonates with you, and if you find yourself longing you could see it for yourself. Maybe one day you'll be standing in the icy dark, staring up, waiting, observing. Or maybe not. Maybe you'll lie here and dream of it, and that dream will be sufficient. Perhaps you will experience the aurora via thought, comprehending its nature and beauty. The aurora can be related to in any way. Who goes to the Arctic, pays money, suffers, and spends hours standing in the cold while watching the lights they're having? One type of experience that is legitimate. The reader who reads about the aurora has a different, but no less legitimate experience when they watch films of it and think about it while sitting in a warm environment. Without the aurora, the person who never considers it in their life is whole. Both those who seek it out and those who do not can find the aurora. Regardless of human attention or lack thereof, it dances in the far north. For millions of years it has danced. For millions more, it will keep dancing. This consistency, this disregard, this perseverance, in a way, is consoling. The aurora serves as a reminder that the universe exists regardless of our own preferences or life experiences. We are a part of a bigger picture that will continue even after we are gone. You may become conscious of your own breathing when observing the aurora in the Arctic night. You can see your breath in the cold. It forms crystalline clouds in front of you. The deep silence makes your breathing audible. In a way that everyday life frequently obscures, you become conscious of your body, heartbeat, and essential processes. In the setting of seeing the aurora, this knowledge of your own breathing and heartbeat establishes a unique connection. Your body is reacting to the surroundings through its rhythms and functions. Overhead, the aurora is dancing with its own rhythms and processes. You participate in the greater cosmic processes symbolized by the aurora, as well as your personal biological processes. This awareness has a reassuring quality. It immerses you completely in lived experience and the present. You're not considering your concerns or your plans for the future. You're just standing, breathing, and observing. The study of presence. We can learn something fascinating about what goes on in our brains when we are completely present, thanks to modern neuroscience. When we're doing what scientists refer to as absorption or flow, certain brain regions exhibit decreased activity during these situations. Particularly, areas linked to self-referential thought and rumination exhibit increased activity concurrently with areas linked to attention and sensory processing. Practically speaking, this implies that your brain is in a position that is advantageous to you when you are completely absorbed in admiring something lovely, such as the aurora. Stress hormone levels fall. There is less activity in areas linked to anxiety. The incessant mental dialogue about the past and the future stops. In this way, the aurora is more than simply aesthetically pleasing and fascinating. It's also healing. Your brain goes into a condition that lowers stress and enhances well-being when you stand beneath it, observe it, and give yourself permission to be totally present to the experience. This is one of the reasons why those who have seen the aurora frequently say that the experience has revived them, as though a weight has been removed. A healing effect is produced by the aurora's splendor and the meditative mood brought on by being in the moment of its magnificence. The unanswered questions, despite all of science's advancements in our knowledge of the aurora. There are still questions. In the magnetosphere, how precisely does particle acceleration take place? What determines auroral features' exact shape? What is the long-term response of the upper atmosphere to auroral energy input? Aurora research is still guided by these and numerous other topics. Science has not failed to answer the questions. Instead, they stand for the boundaries of knowledge, the areas where we still lack a complete grasp. Every question that is answered raises another one. This is how scientific knowledge works. It deepens and broadens, but it never comes to a definitive conclusion. This incompleteness is consoling in a way. It implies that there's always more to learn and fresh surprises in store. In the sense as there are still mysteries surrounding the aurora, it will never be fully understood. You can always learn something new about it. The transition into slumber as our voyage comes to a close. The narrative is coming to an end. You have accompanied us on our journey through the physics of the aurora, the sensation of seeing it, and the cultural and individual significance it holds. You've thought about its enigma and beauty, as well as its relationships to the universe and to ourselves. As this tale comes to an end, give yourself permission to relax even more deeply. While the aurora is still dancing in the far north, you can relax here in the safety and warmth of your own home, bringing the aurora with you in your thoughts and dreams. Maybe your breathing has slowed. Your body has calmed down. After going through so many reflections, your mind is prepared for relaxation. You've been taken to the right place by the story, the last present. As we sleep, the aurora gives us one last present. The gift of reminders. It serves as a reminder that beauty exists beyond of human perception. It serves as a reminder that we are a part of something bigger. It serves as a reminder that the universe is dynamic, active, and ever-changing. It serves as a reminder that things around us are always happening on unthinkable scales. It serves as a reminder that we are interconnected with the sun, the magnetosphere, the solar wind, and forces ranging from microscopic to planetary. We are reminded to look up, observe the sky, and be in awe by the aurora. The aurora urges us to look up in a world where we spend so much time staring at devices. The aurora invites us to venture outside in a world where we spend much of our time alone within. The aurora urges us to be quiet, to wait, to just be in the moment, in a world where our time is divided into little goals and duties, the lights that never go out. Now, as you fall asleep, picture yourself under the northern lights, for the last time. Overhead, the aurora ripples and shifts, turning green, crimson, and purple. There is a tremendous quiet. Though intense, the cold is bearable. Above the aurora, the stars are continuously shining. Witnessing an event that has been happening for billions of years and will continue for billions more, you find yourself in a place of extremes. Innumerable people have seen identical lights and stood in comparable places. In the future, countless people will stand in similar places and see similar lights. You are a link in a chain of observers that stretches both into the future and back into time. But just now, right now, the aurora is all yours. Above you, the lights dance for you. They are timeless, exquisite, and completely unaffected by your presence or absence. And your mind starts to calm as you observe, feel the chill, hear the quiet, and see the lights. The purpose of the aurora is to help you meditate and focus entirely on the here and now. You think slowly, your worries subside. You are merely present, merely here, merely observing. The aurora keeps dancing. It's going to keep happening tonight, tomorrow night, next week, and next year. It will go on once you've gotten back to your regular life, once the recollection of it has subsided a little, and once it fades into the past. Whether you see it in real life or just in your imagination, it will go on. The night's blessing. Allow the aurora's presence to bless you. Let it serve as a reminder of the size of the universe, the splendor of natural occurrences, and the consistency of processes far bigger than yourself, whether you witness it in real life or in your imagination. As you sleep, allow the aurora's memory or your imagined experience to stay with you. Allow the enigma and splendor of the night sky to guide you to sleep and dreams. The aurora continues to dance. The lights in the far north continue their age-old dance despite the extreme cold and darkness. They dance over little human settlements, over uninhabited tundra, and over sleeping animals. Whether someone is looking or not, they are dancing. You can now relax, dear listener. The aurora's story has already been told. The trip has arrived at its last destination. Now allow yourself to fall asleep calmly and gradually. Shut your eyes. Behind your eyelids, allow the vision of the dancing lights to linger. Experience the serenity that results from presence and reflection. Give your body permission to fully relax. Your mind is worn out with all the journey and introspection. It's time to relax. In the far north, the northern lights are still dancing. You can slumber in this cozy and secure location, bringing the imagination and memories of those far-off lights into your dreams. Now go to sleep, listener. Sleep under the northern lights, imaginary or real. Rest easy, knowing that the universe is still going strong. Everything is fine, and the aurora dances. Good night. I hope you have a good night's sleep. May you awaken feeling rejuvenated, remembering the aurora and all the thoughts that accompanied it. Your dreams now keep watch through the night, much like the northern lights do.